Hi, welcome back. I am Professor Ronald Vincent Santiago, and now we will be discussing Module 4, Problems on Unbalanced Systems and Symmetrical Components. The first problem, one line of a three-phase generator is open-circuited, while the other two are short-circuited to ground. The line currents are IA equal to 0, IB equal to 1200 angle 150 degrees, and IC equal to 1200 angle positive 30 degrees amperes. Now, find the symmetrical components of these currents. Also, find the current into the ground. So, what we'll be doing, we'll be solving for the sequence currents I0, I1, I2. These are the zero sequence current, positive sequence current, and negative sequence of the current. And that will be equal to 1/3 multiplied by the A matrix multiplied by the phase value of the currents. And that gives us a magnitude of I0 equal to 400 angle 90 degrees, I1 equal to 800 angle 270 degrees, and I0 or I2 rather, that will be equal to 400 angle 90 degrees. So that gives us the value of the sequence currents in terms of ampere. Now to solve for the current to ground, that will just be equal to 3 multiplied by I sub 0, twice the value of the zero sequence current. So that gives us the current into the ground equal to 1200 angle 90 degrees ampere. Now, the second problem, a balanced delta connected load is fed by a three-phase supply for which phase C is open and phase A is carrying a current of 10 angle 0 degree amperes. Find the symmetrical components of the line currents. So note that the zero sequence currents are not present for any three-wire system. So the circuit will be shown based on the given problem. So notice that IA is equal to 10 angle 0 degree ampere and IC is equal to 0. So with that, IB will be equal to 10 angle 180 degree ampere. So solving for the sequence currents IA0, IA1, IA2, IA0 is equal to 1/3 multiplied by the quantity 10 angle 0 degree plus 10 angle 180 degree plus 0 degree, and that gives us a magnitude of zero sequence current IA. IA1 is 1/3 multiplied by the quantity 10 angle 0 degree plus 10 angle 180 degrees plus 120 degree plus 0, and that gives us a magnitude of 5.78 angle negative 30 degrees ampere. IA2 is equal to 1/3 multiplied by the quantity 10 angle 0 plus 10 angle 180 degrees plus 240 degrees plus 0, and that gives us a magnitude of 5.78 angle positive 30 degrees ampere. So having this zero sequence currents IA0, IA1, IA2, we can now determine the zero sequence currents of IB. IB0, IC0 is just equal to IA0. IB1 is equal to A square IA1, so that gives us 5.78 angle negative 150 degrees amperes. IC1 is equal to A IA1, and that gives us equal to a magnitude of 5.78 angle positive 90 degrees amperes. And for IB2, that is equal to A IA2 equal to 5.78 angle 150 degrees amperes. IC2 is equal to A square I A2, and that gives us 5.78 angle of negative 90 degrees amperes. Now, the third problem, the currents in a delta load are IAB equal to 10 angle 0 degree, IBC equal to 12 angle negative 90 degrees, and ICA equal to 15 positive angle of positive 90 degrees amperes. Now, we need to calculate the sequence components of the delta load currents denoted by I delta 0, I delta 1, I delta 2, and B, the line currents IA, IB, IC, which feed the delta load, and C, the sequence currents of the line currents IL0, IL1, and IL2. And also, we need to verify the following general relation: IL0 equal to 0, IL1 equal to the square root of 3 multiplied by I delta 1 angle negative 30 degrees, and IL2 equal to square root of 3 multiplied by I delta 2 angle of positive 30 degrees. So our solution now will be equal to get first for letter A, determining the sequence currents components of the delta connected load. This will be equal to 1/3 multiplied by the inverse of the A matrix multiplied by the currents flowing through the delta connected load. And this will give us an angle of, for IA0, that will give us a magnitude of 3.48 angle of 16.7 degrees amperes. IA1, that will give us 11.14 angle of negative 2.58 degrees amperes, and IC1 equal to 4.49 angle of negative 173.6 amperes. Now, for letter B, we need to get the line currents IA, IB, IC flowing through the line. IA is equal to, since the load is delta connected, so IA is equal to IAB minus ICA. So we just need to substitute the values. So that gives us IA to be equal to 18.03 angle negative 56.3 degrees amperes. IB, which is IBC minus IAB, so that gives us 15.62 angle negative 129.81 degrees. IC, which is equal to ICA minus IBC, and that gives us 27 angle of 90 degrees amperes. And for letter C, the sequence currents of the line is equal to 1/3 multiplied by the inverse of the matrix multiplied by the line currents IA, IB, and IC. And that gives us IL0 to be equal to 0, IL1 to be equal to 19.29 angle of negative 32.57 degrees, which is also equal to the square root of 3 multiplied by the current in delta 1 angle of negative 30 degrees. Then for IL2, that is equal to 7.77 angle of negative 143.59 degrees, which is also equal to the square root of 3 multiplied by the current in delta on the zero sequence network, angle of negative 30 degrees amperes. So that ends our exercises in Module 4.